So hey nerds, this is Suman, and in this video we're gonna talk about whether the integration is scalar or vector. Right? So the first thing is first, the integration is actually scalar as well as vector. It depends on how you are doing your calculation. If you are taking the scalar field, the integration gives the scalar field, and if you are taking it as a vector field, the integration would lead us to give a vector field. Right? So let us dive into the whiteboard. So here in the board, you can see the two examples. I have taken one example is the temperature, and we all know that the temperature is a scalar quantity, and I have used here is acceleration. So if my words are wrong, you might know the acceleration. Acceleration is a vector quantity, right? So if I had a temperature is function of time, so that means what is the meaning of temperature is function of time? So it means that the temperature depends on time. So at different time, the temperature could be have different values. So this means the function why we are using T as function of time. It is not in the multiplication. Temperature is function of time. The small t is time and capital T is temperature, right? So this I represents integration. So if you integrate temperature with respect to time from 0 to 5 seconds, so what will end up? So you have 0 to 5 here, and this is temperature, it is a scalar. So what the value of this is 2t dt, right? And if you take integration, you will end up getting t square upon 2, 0 to 5, and you will end up getting 25. And if you want to write the unit of this, it is whether you have used Kelvin, or you can use degree Celsius second. So it is actually the scalar. So this will end up giving you the scalar quantity, right? So and we know that if the acceleration right here, if acceleration is also function of time and it depends on time, for different moment of time, for 1 second the acceleration could be 2 meter per second square, for 2 seconds it could be 4 meter per second square. So the acceleration also depends on time, and it is approaching towards, assume, let us say, x-axis. So we are just looking the motion of particle along the x-axis, right? So acceleration is nothing but rate of change of velocity with respect to time. So if you do something like that, you will end up getting a vector dt, you will end up getting dv vector, and if you integrate both sides, you will get v vector as integration from a vector dt. So we are all similarly we are looking for a time gap 0 to 5 seconds, right? And taking the same example. So this is velocity. We will end up getting, if you integrate acceleration with respect to time, you will end up getting velocity vector of that particle. So this is nothing but 2t I cap dt. The I cap represents the direction. I think you know some of the basics of vector calculus. So v vector can be represented 2 I cap. This is nothing but t square upon 2. So if we have limit from 0 to 5, we can use from 0 to 5, and we get same result, 25 I meter per second. So isn't this beautiful? So integration of scalar versus integration of vector. So from this conclusion you can conclude that the result of integration can be either scalar or vector, depends on what you are dealing with. If you are dealing with scalar field, you will end up getting scalar quantity, and if you are dealing with vector field, you will end up getting vector quantity, right? So this was my time. Bye bye.